Hi everyone, my name is Nibara Makola. I am here going to help you today with a welding level 3. So I am employed at the Ngangala FET College in Witbank campus. I am on welding. So today we're going to be talking about welding. So I am going to be using this textbook that I've got today is Pearson. That's the one we're going to be using today. So if you've got it at home, you can just grab it, get your script and a pen so that you can put down some notes while I am talking here so that you can be able to go through them yourself after this show. So what we're going to do today in this welding, we're going to be looking at topic 1, which we're going to be talking about the principles of arc welding. So in this topic, what is included is the basic techniques of welding steel. That is what we're going to be looking at. And then we're also going to explain the types of the welding joints on blades. And then again, we're going to explain steel in terms of welding capacity. That is the things that are going to be covered when we are doing this show today about e-welding year 2. So what I can go into today, we're going to look at how to describe the nature of non-alloy steels. So in welding, we use steel. We work with steel. So it is important for you to remember to know and understand the types of steels that you need to use so that we don't make mistakes and then we are familiar with the material that we have to use. So now we're going to look at the non-alloy steels. The non-alloy steels that we're going to be talking about, they are made of iron and carbon. So in the non-alloy steels, we've got 3 categories of the steels. So they are categorized in this way. We've got the low carbon, we've got the medium carbon, and the high carbon steel. So what we normally use in the welding, mostly we use the mild steel, which is the medium carbon. So when we check at the carbon contents of the steel, the one that we are using, the mild steel, it contains the 0.3 and 0.6% of carbon. So what we need to know about this carbon is that the amount of carbon that is added on the material, it determines the hardness and the ductility of the material. So it means that in welding, as much as you add the carbon on the steel, it increases the hardness of the steel and it also reduces the ability of welding. So the mild steel that we are using is used for general purpose. So when we discuss this alloy steel, what we're going to look at on this alloy steel when we weld, there are some effects that happens as much as we weld. So when we are welding, we sometimes encounter problems like distortion. What do we mean by distortion? Distortion, it happens when you weld too much on the steel, over welding. That is one of the results of distortion. So if you weld too much on the material, it distorts, it moves out of position, it changes its shape. So that is one of the effects that we encounter when we are doing our welding on the steel. So to avoid that, what do we need to do to avoid the distortion? So to avoid the distortion, you don't need to overweld on your material. You need to plan your welding sequence properly. You must take weld your workpiece as much as you can. So when you take welding your workpiece, you are helping the workpiece to be in position when you weld. Because now when you are welding, you are putting heat on the 2 materials that you are welding. And as much as you weld, the heat input on the material, it affects the strength of the material and also the contents of the material, the properties of the material. What happens when it affects those properties of the materials? It moves out of shape. It stretches as you weld, and then as soon as you finish, it cools down. When it cools down, it shrinks. That is what we call the distortion. It changes its shape. So it is important to always remember what do I need to do to avoid distortion? I'm going to do a rough sketch here on the board to show you how it happens, this distortion that we're talking about. So what happens is this. Now this is your workpiece. Now this is your workpiece. Let me put just a plain plate. Now this is your workpiece. This is your workpiece. So when you are welding on this workpiece, what's going to happen? When you put too much welding on your workpiece, now we're going to do strings on the workpiece. So now you are welding the first string, the second one, the third one. Remember, when you put the first one, it has got its heat input on the material. You weld the second one. So as much as you weld, you are adding too much heat on the material. So when you put more runs at the same time on the workpiece, what's going to happen? The workpiece at the end is going to move out of shape. I'm just going to show you with the dotted lines how it's going to happen. So now the workpiece is like this. Now you have welded. The workpiece is going to move out of shape. It's going to move out of shape. The workpiece is going to move out of shape. It's going to move out of shape. It's going to warp. The workpiece is going to warp. It's going to move out of shape. So why does it move out of shape? It's because of the heat input. It's because of the heat input. So this is the original shape of the workpiece, the black one. The green one is the workpiece after welding. What has happened? The workpiece has moved out of shape. It has warped now. This is what happens after welding. The original shape of the workpiece was this one. So now you have welded too much on the workpiece, and then now it is being affected by the heat input. So what do we need to do to avoid this? You need to plan the sequence of your welding. So now, if your workpiece is like this, you have to weld, you put one run, you leave it, it cools. And then you put the second one, you leave it, it cools. And then you put the third one, you leave it, it cools down. And then now, the heat that is being put on this workpiece, it will not affect the shape of the workpiece because the sequence has been planned so that the heat does not affect the shape of the workpiece. So it is important to always remember when you are welding that you need to plan your welding. So now, after this distortion, we can now talk about the welding joints types, the types of welding joints. So now when you weld, on the welding joints, the types of joints, each joint has got its own way to be affected by the distortion. Now I'm going to do it like this to show you how to avoid distortion on workpieces, the types of joint that we're going to be working with in our welding. So now I'm going to start with the fillet. We've got two types of welding joints. We've got the fillet types of welding joints and we've got the bar joints. So now, what I'm going to do is this one. On the fillet joint is a joint that is in a form of a T. It's a joint that is in a form of a T. So now, we've got the best sketch on that side that I've already prepared, and then we can look at it as well. So this is now our fillet joint. So how do we avoid distortion on a fillet joint? What they say is that you can also weld on this side and weld on this side, on both sides of the workpiece. So what happens on this T-joint? What happens on the T-joint is that now, I'm going to show you the T-joint, the other side of the T-joint. Now this is our fillet. I have welded here. I have welded on that side. I have put maybe 3 or 4 runs on this side. So what's going to happen with the distortion on this piece? What's going to happen is that the heat, as soon as the workpiece cools off, as soon as the workpiece cools off, the heat, as soon as the workpiece cools off, it's going to pull the workpiece. This is what's going to happen if we don't plan our welding sequence. The welding, as soon as it cools off on the workpiece, it's going to pull this thing out of line. Now this is what we call the distortion. What happens on the bars? On the bar weldings, this is what is going to happen. Now this is a square bar. Now this is a square bar welding. Now I have welded here. This is my welding here. I have planned my sequence. The workpiece is still in shape. What will happen if I haven't planned my welding properly? This is what is going to happen. As soon as the workpiece cools off, as soon as the welding and the workpiece cools off, this is what is going to happen. It's going to move out of shape. And now, this is what we call distortion. So how do we avoid that? We don't overweld, number one, to avoid this distortion. We do not overweld. So what does it mean by overwelding? It means that now when you weld, they required you to put only 1 run on the workpiece. And then now you're going to put 3 runs on the workpiece. You're going to put 3 runs on the workpiece. They asked you to weld the workpiece on the WPS, and then you're going to put 3 runs on the workpiece when they have asked you to put only 1 run. So this means now it's over welding. So we need to avoid this over welding by planning our welding sequence. Normally people do this over welding because they want to rectify some mistakes on the previous run. So the only way to rectify a mistake on the previous run is to grind it off and start afresh. That is the only way to fix mistakes. So we really need to avoid this over welding, because now we have standards that rules our work. We have standards that rules our work. We've got the ISO. It's the International Standard Organization. It is responsible for providing standardization for products, material in the industries. So what do we mean by that? It means that now, if in another country they are asking you to do a 1F workpiece, it has to be a 1F workpiece. Even if it leaves South Africa to another world, it has to still be 1F. So we are governed by the International Standard Organization. That is the one that is ruling all the work that we are doing in welding. So now, in welding, as I say, we've got the types of joints. With the fillets, we've got positions in the fillet weldings. So we've got the 1F, which is a flat position. The flat position is going to be like this. The flat position is going to be like this. So now, this is my workpiece. This is my workpiece. The workpiece is tilted. I tilt my workpiece now to make a 1F. So I am going to weld on this part. So this one is going to be the 1F, the flat position. And then we've got 2F. The 2F position is going to be a horizontal position that is going to be in this fashion. So this is my workpiece. When you are looking at it from the front, this is going to be my workpiece. You can also put it like this. The workpiece that is 2F. The 2F position is a horizontal position. It's not a flat position. So the 2F, we're going to weld on this part as well. It's going to look like the wall of your house and the ground level. And then you're going to weld between the ground level and the wall. This is what we call the horizontal position. And then again, on the Fs, we've got the 3F position, which is going to be a vertical up position. So the vertical up position is going to be in this fashion. The vertical up position, we're going to weld from the bottom to the top. The vertical up position, we're going to weld from the bottom to the top. This is going to be my workpiece. So I'm going to weld from this part going upwards. This is the 3F position. This is the 2F. What else do we have in these positions? We also have got the 4F position, which is the overhead position. We're going to weld above your head. So this one, when you look at this type of a welding, you're going to weld from above your head. It's going to be in this way. So when you are doing this one, you're going to weld either from this side or this side, above your head. So in hidden details, this is going to be your welding. So you're going to weld above your head. Your welding is going to be at the bottom here. So with the hidden details, you can see this is my welding under there. This is what we call the 4F. The 4F positions. So now, these are the fillet welds that we've got. And then now we've got the bars. With the bar welds, the workpieces are put head to head together. The workpieces are put head to head together like this drawing that I have put here for you to see. So this is what we call a bar. This is what we call a fillet weld. A bar weld and a fillet weld. How do we differentiate? In this bar welds, we've got types of bar welds. We've got the single part, we've got the bevel, and the double. So how do we know the difference between these two, these types of parts? So we've got this one. We've got the square part. The heads are put together with a space between them to allow the welding to fuse so that there will be penetration at the bottom, at the root there. This is my welding on top, and this is going to be the penetration. So this one, this type of a welding, it is determined by the thickness of the material. So the thicker the material, we need to do the single V. I mean, we start with the bevel. Now we start with the bevel. With the bevel welding, only one side of the workpieces, one of the workpieces has to be beveled. Only one on one side. The other part must be left square and the other one must be beveled. This is what we call the bevel welding. And then, why do we have to do this? The reason why we have to do this is because of the thickness of the material. So the thicker the material, the more we have to bevel. And then we've got the double. I mean, we've got the V now. We've got the single V. So what do we mean by the single V? The single V tells us that now our workpieces are in a V shape. Why do we have to do them like this? We need to improve penetration and strength. The reason for us to bevel them like this is because of the thickness of the material. So this one is the normal plate. You will find that it will be the 3 millimeter plate, for example. It's too thin. You don't need to bevel that plate. So the reason why we bevel here is because of the thickness of the material. And now we've got the double V. Now we've got the double V. Why do we call it the double V? It's because now the workpieces, both the workpieces are being beveled on both sides, the top part and the bottom part, the top part and the bottom part. So when you look at them, this is a V shape here, and this is another V shape. So it tells us that now this material is very thick. It needs to be beveled on both sides to improve the penetration and the strength of the welding as soon as we finish. That is what it is about the bevel joints. So now, as we spoke about the distortion, that we need to avoid distortion. These are the most of the weldings where you will be affected by the distortion. Now, what you need to do to avoid distortion, you reduce the gap between the two. By reducing the gap, it reduces the size of the opening. So as soon as you reduce the size of the opening, it reduces the number of runs that you're going to put on your workpieces. That is how we need to avoid over welding so that we will be able to overcome the distortion. It is important always to consider your current setting when you are working with these types of weldings to avoid distortion. All right, now we've got ways of preparing our workpieces. How do we prepare the workpieces? It means that we have to clean our workpieces, and then we have to do the correct setup. How do we manage that? One of the other ways to do it is by beveling the workpieces. You bevel the workpieces. How do you prepare them? You bevel them. And again, what do we need to do is to clean the workpieces, the surfaces where we're going to weld. We clean them. We remove any dirt on the workpieces. Why do we need to do that? To remove the dirt on the workpieces, the rust, the grease, the paint, and all that. The reason for us to do that is to avoid welding defects. Because if we don't clean our workpieces, if you do not clean your workpiece, there will be defects on the workpiece. So what defects do we have on the workpieces? Once we don't clean our workpiece, we're going to have porosity. How do we know porosity as a defect? On your workpiece, now you have welded on your workpiece. You have welded on your workpiece now. So when you have welded on your workpiece, everything looks fine from the top. This is the welding. Everything looks fine from the top on your workpiece. So we know everything looks fine, but is it the correct welding that you have done? How do we know that? By checking for defects. What defects do we have on the welding? We've got the cracks, we've got porosity, we've got lack of fusion, and incomplete penetration. So now what we're going to do is we're going to cut the workpiece here to check for defects. If there's nothing on top, the welding looks good. We're going to cut your workpiece. Now let's say you have done a single V butt welding. What do we do on the single V butt welding? After having cut the workpiece, this is what we're going to see. This is the welding. This is the workpiece, this is the welding. Now we have cut the workpiece into half. There's no defect that we can see on the outside. How do we check now? We're going to look on the inside. This is what we're going to see if there will be any porosity. So porosity, it will appear as a cluster of bubbles on the surface of the welding or inside the welding. So what we call this one porosity now, this type of porosity that is on the inside, the porosity that is on the inside, we call it the subsurface. It's inside. So if it's on top here, on the outside of the welding, we call it the surface. It's a surface defect. This is a subsurface defect. It's a porosity that is inside your welding. So with the cracks, how do we know the cracks? How do we see cracks on your welding? Now we have cut the workpiece. How do we see cracks on your welding? If there are cracks on the inside of your welding, we're going to see them on the inside as soon as we cut. If we can't see anything on the inside, on the outside of your welding. So on the inside, what we're going to see? We're going to see some openings on the inside. So this causes of the defects. The porosity is caused by dirty plates. If your workpieces are dirty, you haven't cleaned them. As we say, we have to prepare our workpieces. Dirty plates, they cause porosity. The current that you are using, the current settings on your welding machine that you are using, it also affects, it causes porosity. You find that you are using too much current. The current setting is too high. So what is it going to do? It's going to cause porosity. Okay, now as we have spoken about the types of weldings and the material that we are using, the mild steel, the high carbon steel, and the low carbon steel, and also the positions, the defects. We have come to the end of our show, and then we will proceed again later to see how far we can go with our lessons. If you also need to ask a few more questions concerning the lesson for today, you can also go on the Facebook page of our college, Nkangala FET College. You'll find us there. You'll be able to ask questions. Our WhatsApp number is also appearing there. You can also ask questions there. Also on YouTube, you can go there and then you'll find us there if you need anything. I hope this will be helpful to you. Thank you.